so that we can finish this in the next week. It has how many? 28, and nothing is, we don't have to leave anything in this. We have to cover all these slides. Okay. So this is the last CO, that is about abstraction. Maybe there is some slide where I have mentioned. Okay, anyhow, that is about abstraction and interfaces. That is about abstract classes and interfaces. Abstract classes and interfaces both are used for abstraction. So what is abstraction, by the way? What is abstraction? Abstraction is hiding implementation details of your program from an end user. That is called abstraction. For example, if you will see some article, then maybe in that article you will see the first heading abstract, and then maybe some one paragraph, and then afterward you will see the introduction, the literature, the methodology, the quite very much detailed things there. But first, I am sure that maybe you have seen some research article, and in that research article first you have the heading abstract with only one paragraph. So that abstract heading abstract with one paragraph has some meaning. What is the meaning? That a reader can read this abstract, only one paragraph, that a reader can read that abstract with only one paragraph, and then can have the idea that what is in this whole article. Similarly, abstraction, the concept is same basically. The concept is same. You will hide the implementation details of your program from the end user, the user of your software. You will hide the details from that user because you are a programmer. You will hide the details from that end user. You will give only the abstract information to the end user. And abstract information means what is the other words in English? The short information. Abstract information means the short overview, not the detail. I don't know, the satha or satahi is a Arabic word. Okay. So anyhow, now moving on. Where is the pointer? Yes. Now, first we will see the abstract classes, and then we will see the interfaces in this lecture. So what is abstract class in Java? A class which you can declare or write by using the keyword abstract. This is the abstract keyword. You have to use the abstract keyword if you want to write an abstract class. So a class which is declared with the abstract keyword is known as abstract class in Java. And in abstract class, you can write abstract and non-abstract methods. And in the class, you can write abstract and non-abstract methods. So here we have got some information that if we want to write an abstract class, then we have to use the keyword abstract with it. That is okay. And in the abstract class, we can have the methods. You know what is method. A method can be abstract or cannot. And if you want to write an abstract method, then abstract keyword would also come before it. So method can also be abstract. So in short, in an abstract class, you can write abstract methods or non-abstract methods. And the methods which will not have the abstract keyword with them, those methods would be called non-abstract methods. We will see examples. And what is abstraction? This is the definition. Abstraction is the process of hiding the implementation details. Hiding the implementation details. Implementation details mean you will hide some of your code from the end user, which is not needed to that end user. End user means the last end user of your software, of your application, of your program. So hiding the implementation details and displaying or giving or showing only functionality, the operation of your program. Only the operation of your program. So that is called abstraction. This is a general example from the real life, not a source code example, not a Java example. For example, when you will send some SMS, you normally type some text and then you have the phone, you will type some text and then press the send button, it will be sent. You don't know how that message is sent to the other user. What are the technical details involved between the two phones, how the message is going out from the phone first and then traveling in the medium and then receiving on the other phone. So you don't know those technical details. You only know that message is sending. So that sending is functionality. Sending the message is functionality. But you don't know the technical details, the medium, the different towers, the networks that are involved between that thing, you don't know. So this is an example of abstraction. So this is an example of abstraction. And you already have seen the abstraction example in CO1, in chapter 1. We can achieve subtraction by two ways. First way is we can achieve abstraction by using abstract classes. Second is we can achieve abstraction by using interfaces. And if you will use abstract classes, then you will get abstraction from 0 to 100%. It will change between them. So in the meaning of this sentence, this thing is that you will not it is possible that you can get 100% abstraction through abstract classes, but most of the cases not. There are something that you will declare in your class as non-abstract things. So due to those non-abstract things, then the percentage of 100% is reducing if you are using abstract class. So abstract class can give you abstraction from 0 to 100%. It is not fixed. And interface will give you 100% abstraction. It will give you 100% abstraction. We will see. So now abstract class in Java. How you can write abstract class in Java? This is the way. Class, and this is the name of the class. This is a starting bracket of the class, ending bracket, and then you have the abstract keyword before it. It is just underlined. So you have to write this abstract keyword before it. The rest of the things are same as you have for the class. And rules for Java abstract class, these are some rules that you have to, these are the syntactical rules or usage rules. So if you want to declare an abstract class, first you have to use the abstract keyword as we are using here. This is rule number 1. Rule number 2, abstract class can have abstract and non-abstract methods. You can write abstract and non-abstract methods in an abstract class. And then it cannot be instantiated, which means if you have the abstract class, you cannot create an object of that class. Instantiate it. Okay. It can have final methods. You can introduce final methods. The methods with keyword final. Those are called final methods. So you can introduce final methods in an abstract class. And it can have constructors and static methods. So in abstract class, you can introduce constructor of that class, or you can introduce some methods which has the static keyword, which will have the static keywords. Or you can say you can introduce static methods and constructors in an abstract class. So these are some rules. This is the definition for the method, abstract method. I already told you what is abstract method. A method which will have the abstract keyword, that would be called abstract method. Okay. Or a method which is declared as abstract, which will have that abstract keyword. This is additional information and does not have implementation. So a method which will have the abstract keyword, but then that method will not have the body. Does not have implementation means will not have the body. It is only a one line. So that method would be called abstract method. Example. What is example? You can see here. Print status is the name of the method, and these are the parentheses. And this void is the return type of that method. And then you have the keyword abstract. So when you will write like this, abstract, void, some method name, you can pass arguments or not, it is up to you. But then we don't have the curly bracket starting and ending, because abstract method does not have implementation details. Because abstract method does not have method body. So that's why this is the only thing. After that, khalas, finished. This is the only one statement needed for the abstract method. The body of that method, the body of that abstract method would be at some other place. Would the body of that method, the statements of that method would be at some other place. And that place is hidden from the end user. Without body of that method, we cannot execute anything, okay? But this abstract, this statement we will give to the end user, but we will hide the detail of this method that would be available somewhere else. Keep this concept until I reach at that topic. So now we are going to see example 1. In this example, we have the abstract class and the abstract method. In this example, we will have a class bike, which will be an abstract class. And if it is an abstract class, that would contain abstract methods. So that will contain one abstract method. The name of that method would be run. And I told you that the implementation detail of that abstract method would be in some other class, that is the Honda class. So let's see here. So here we have some abstract class. This bike class is abstract class because abstract keyword is written there. So when you have the abstract keyword, with the name of the class, then that class would be abstract. And that class can contain abstract methods and non-abstract methods. That class can contain final methods, can contain constructors. What are the 5 rules in the previous slide? You can remember those 5 rules. And in that class, now we have an abstract method. The name of the method is run, the return type is void. And why I am saying it abstract? Because the abstract keyword is there. So this method run is abstract keyword, abstract method. Semicolon. So this is a method, but it does not have the body. Where is the body of this run method? That body would be available in some other place. What is that other place? We have another class. The name of that class is Honda 4. And this class is extending this bike class. So now this bike class is the parent class. And this Honda 4 is the child class of this abstract bike class. Okay. So this Honda 4 is now the child class of this bike class. So now this bike is parent. This Honda 4 is child. And here we have the body of that abstract method, run. So whatever the abstract method you have, you can write the details of those abstract methods in the child class. Okay? In the child class of that abstract class. Now you know where you have to hide the details. In the child class. In the child class, you can hide the details, or you can provide the implementation details of those abstract methods which you have written in the parent class. And here this run, which is that. So now you have to write that method without this abstract keyword here in this child class, and void run, and then starting curly bracket, ending curly bracket. So this is the body of that method is now system.out.println and running safely. So we are printing one message. You can do whatever you want in this method according to your need. And then we have the main method in this child class, starting from here, ending here. And in the main method, when you will run this program, the main method will be identified and executed. And in the main method, we are creating an object, bike obj. So this is the left-hand side has the parent, and the right-hand side has the new Honda 4. So this is new Honda 4, the right-hand side. This has some effect. So that's what. Due to this abstraction, we are doing that. The left-hand side has the object type parent class, but on the right-hand side, we are creating the object for the child class. So this is, we already saw what is happening here. We already saw this mechanism in previous chapters. Do you understand or not? How many people know that we have already did something in the previous chapters? Just raise your hands. How many people know what is happening here? I am saying that the left-hand side and the right-hand side of this object creation statement is different. Okay? So I am asking how many people know that what it is. Here what is happening, due to this right-hand side, we are calling, basically here we are calling the default constructor of this Honda class. So, okay, this is, if you will forget this left-hand side, okay, this is the reference of an object for the child class. That reference we are storing in the parent class, nothing else. If you remember the topic of overriding, I think. during static polymorphism, dynamic polymorphism, and then overriding method. At that topic, we have seen something there. Because you know that there is some topic, overridden method, and there is overriding method. So overridden method is what? Overriding method is what? Overridden method is a method which is available in the parent class. Overriding is a method which is available in the child class. And when you will do like that, left hand side is different, right hand side is different. So when you have the left hand side as a parent and right hand side as a left, only then you can access the overridden method. So this is what we started from that topic, and after that we use this type of thing on many places. Anyhow, so this is simply an object creation. The name of the object is obj. And when you will write, now after that, when you will write obj.run, so obj has the type bike, so I will go into the bike first. And I will search for this method run. Okay, so I have the method run there, but it is abstract. It means that the body of that run would be available somewhere else. So then what? This object has the right hand side. What is that right hand side? This has the reference of that child class. So actually in that object, you have the reference of that child class. So you will go. So then compiler will go into that child class. It will search this run method again. It will find that method again. And then it will execute this statement running safely, which you are seeing as an output. So basically it is a check that first you are going into an abstract method and then looking for that method is an abstract method. So that is first. And if it is an abstract method, the body of that method would be available in the child class. Then you will go into that child class and you will find that method again, and then you will execute the body of that method. Anyhow, understanding now the real scenario of abstract class. So in this example, now we have one abstract class. The name of that class is shape, and its implementation is provided in the rectangle class and the circle classes. Let's have a look directly here. So here in this example, we have some class which is shape, which is an abstract class. And then we have the class rectangle, which is the child of that abstract class. And then we have the class circle 1, which is also the child of that shape class. And then we have another class, test abstraction 1, starting from here and ending here. When you will run this program, it will search for the main method. Main method is available there in this test abstraction 1 class. So this main method will be executed, and here in this main method, we have this statement first. And what is that statement? Shape S is equal to new circle 1. So this shape is abstract class. This new circle 1, this circle 1 is the child class. Okay, so here new circle 1. So let's have a look over this circle and shape classes. So this is class circle 1, which is extending shape class. Shape is this class, which is abstract. So this circle 1 is now becoming the child class of this shape class. And this circle class has only one method, draw. Anyhow, so first see this shape class. This is an abstract class shape, and it has one method, which is void draw. and this is abstract. So this is our abstract class. And now this circle class, this has void draw. That method again here, void draw, with the same name, same arguments, whatever it has. And this is the method body, which was not here. So system.out.println drawing circle. So this is, we are printing some message through this circle class. And similarly, we have another class rectangle. So this is the child class extending shape. So the parent of this child rectangle class is also the same abstract class. If it is that thing, then we can introduce this method again, void draw. It is again the same thing. Starting bracket, ending bracket, and we have the message drawing rectangle, not circle. Here we are saying drawing circles. Here we are saying drawing rectangle. Now come here. In the main method, we are creating first shape as new circle 1. So we have the reference of the new circle 1, which is this one. And we are storing that reference in S object, which has the type shape, which is a parent. And when here, this is an object, okay? When you write s.draw, so then what? What is S? The compiler will look, what is S? S is the shape. So okay, it will go to the shape and it will search for the draw method. Okay, it will go there. And we have the draw method there, but it is abstract. It is abstract, then it means that the detail is available somewhere else. How can I find how this statement, object creation statement, the right hand side will give you the understanding where you can find that method. So that circle 1, so draw. So it will search there first in the parent class, draw is available, but detail is not available. But this object S has the reference of this circle 1, which is the child class. So then after that, you will go into that circle class. And in that circle class, you will find the draw there, and then you will execute it. System.out.println, drawing circle, that will be printed on the screen, and not this one. If you want to execute this rectangle, put here new rectangle here. You will, when you will change this one, then this method will be executed. You will see examples next. See you. See you again, huh? Okay. Okay, I will start from here, inshallah, in the next lecture.